All right. So guys, let's solve some numericals on Mohr circle. Now, before solving any Mohr circle numerical, I just quickly want you people to just keep these two formulas in mind. What is center of Mohr circle? It is given as sigma x plus sigma y divided by 2, comma 0. And the radius of Mohr circle will be given as either sigma 1 minus sigma 2 divided by 2, which is nothing but our principal stresses. Or if you don't want to use this formula, you can always use this formula. Keeping these two things in mind, let's go to the numerical. This question is asked in 2022, question number 28. So this is asked for 2 marks. All right. Let's read this question first. If sigma and tau represent the normal stress and shear stress on a plane respectively. All right. So normal stress is represented by sigma. Shear stress is represented by tau. The Mohr circle that may possibly represent the state of stress at point in a beam of rectangular cross section under pure bending is or are. So it's a multiple select question. It can be anything. Now please listen to this very carefully. They are asking us to draw Mohr circle, for which case they ask us to draw in a beam of rectangular cross section under pure bending. So first of all, we should know what kind of loading is provided to us. So let's say you have a beam and pure bending means you are simply applying movement to it. M is the bending moment. How you bend a stick, right? If I'll give you a stick, how you will bend it, that is nothing but pure bending. There are no shear forces. Now, before drawing any Mohr circle, if you see in the formula, we need sigma x, sigma y, and we need tau xy. If we know these three things, your answer is clear. Now, in bending, you people should know this. If you don't know bending, it's perfectly fine. Just take it as a formula for now. In bending, the stresses generated will be, in pure bending, the stresses generated will only be normal stresses. So what you will do, you'll take a small element here. That's what they say, right? State of stress at point. And I told this in my lectures also. If you zoom this, it looks like this. This is known as state of stress. And in bending, the stresses are the normal stresses which acts perpendicular to cross section, sigma x. There will be no stresses in y direction because no one is doing anything in y direction, right? And there will be no shear stress because there is no shear force. So the only stress in bending which is generated is nothing but in the x direction. Now you should not worry about, but ideally speaking, this formula of normal stress is basically m divided by I into y. Don't worry about this because I'm not teaching you bending as of now. But the only thing I want you people to remember for now is that in bending, the stresses will be always perpendicular to cross section. Stresses will always be perpendicular to cross section, and that we have marked in our stress element. So you have sigma x. I'm not interested in the value. This is non-zero. That means there is a number. Sigma y is 0 and tau xy is 0. For this case, what is the possible Mohr circle? What do you feel? So Divya and Dave already gave me an answer, but still I want you people to think about it. Now, if I go to center of Mohr circle first, center of Mohr circle says sigma x plus sigma y by 2. In this case, sigma y is 0. So your center of Mohr circle becomes sigma x by 2, comma 0. Always Mohr circle is on x-axis because y coordinate is always 0. And you got sigma x by 2. Now, guys, non-zero. That means your circle can be on the left-hand side. It can be on the right-hand side. Now, the mistake you people have done, Divya, Dev, Rohit, all of you, This shear stress, this normal stress can be positive or negative. It depends upon what kind of movement you people are applying or where the state of stress is taken. You will learn this later, that in bending, this is the neutral axis. And when you bend this beam, right, this beam will become something like this. When you bend this beam. And when you bend this beam, if you see the upper portion, this is in compression. That means someone is compressing it. If you see the bottom portion, this is in expansion, as if someone is expanding it, try to make it big. This, you people can imagine this in your mind. If I'll give you, let's say, a box, right, and ask you to bend it, you can imagine, or you can imagine this in your mind. The top surface, when you bend, will be compressed, and the bottom surface will be expanded. Meaning, on top surface, you have negative stresses, compressive stresses, and on bottom surface, you have tensile stresses. Correct? So sigma x can be positive or negative depending upon whether you take your stress element on top side or on bottom side. They say represent the state of stress at points in a beam, and this is the reason they say is or are. So which one of them represents the correct formulation? All right. So your center of Mohr circle is sigma x by 2. It can be positive, it can be negative. That means your circle can be, this is center, right? This is also center, this is also center, this is also center. All cases are possible. Let's calculate the radius of Mohr circle now. So to make our option clear, when you substitute radius of Mohr circle values, if you people see tau xy is not present, sigma y is not present. So you only have your radius of Mohr circle as sigma x by 2. Now your center is this, your radius is this. What you people expect? If I draw Mohr circle with positive, assuming that sigma x is positive tensile, it is here. This is sigma x by 2 comma 0. Your radius is also sigma x by 2. So if you from here measure radius and then draw a circle, if you people expect, it will be something like this, right? You can imagine this is radius sigma x by 2. Now if someone has draw the Mohr circle when sigma x by 2 is negative, that means you are here minus sigma x by 2 comma 0. Radius remains same. So if you draw the circle, it will look something like this. So which of the options here makes sense? Option B and option C both make sense. You have to touch the y-axis like a tangent. So this option is wrong, this option is wrong, and we have B and C as an option. Is this part clear? It looks simple, but it is not. We have already solved one numerical, y center is negative. So Rohit, just understand one thing. All right, Rohit, can I unmute you? Just for the easiness of other people, so that everyone is clear with this. I want everyone to be very, very much clear in this numerical. Rohit, is this, am I audible?
Yes, sir.
So Rohit, just understand this way. Is this part clear that your radius of Mohr circle is this? Are you clear with it?
Yes, sir.
All right. Now what I am saying is, when you have bending, right? Let me draw it here. When you have a beam like this and you apply a movement like this, what do you expect how beam should bend? This beam should bend like this, right? Yes or no?
Yes, sir.
All right. So when beam bends like this, if you see this top portion is in tension or compression,
Compression.
Compression. You are compressing it, right? It was straight
Yes.
and you are compressing it. What do you mean by compression? Negative,
Compression is also negative.
negative stress, right? So meaning in this top portion, your stresses acting are actually into the system. Whereas if you see this bottom portion, what you feel, this is expanding or compressing?
Expanding.
This is expanding, right? See, this is the length. If you bend it, imagine in your mind what will happen to this below fiber. It will expand, right?
Yes.
So below portion is actually experiencing expansion, means tensile stresses.
Mhm.
All right.
Yes, sir.
Now they ask us to draw more circle for a state of stress at point in a beam. Now they don't mention like this point should be here or it should be here. So if you take this section which is on top, the stresses acting here are this, and its magnitude will be sigma x. So is this sigma x positive or negative here?
It's negative.
And if you take any section on bottom, how the shear stress will, how the normal stress will look like? It will be this.
Tensile and positive.
So they say for bending, how it looks like. It can be anything, right? Your normal stresses can be compressive or your normal stresses can be tensile. It can be anything, correct? So what is the formula for your Mohr circle? It is sigma x by 2. So when sigma x is positive, can you tell me what will be the center? Let's say your sigma x is 100. Just take an example. Your sigma x is 100. So what is center for Mohr circle in this case? In this case, center of Mohr circle
It's
will be 50
50.
by 2. What is center of Mohr circle in this case?
It's minus 50.
Formula is this, but sigma x can be positive or negative both, right? So one possible solution is that center of Mohr circle is at plus. Another possible solution is that center of Mohr circle is at minus. Is this part clear?
Yes, sir.
All right. Now you need to calculate the radius of Mohr circle. Radius of Mohr circle always came out to be what? Radius is a distance, right? It cannot be positive or negative. Radius can be anything. Now, if you draw a circle with Mohr circle at this center, which is positive, radius is sigma x by 2. And if you draw a circle, your circle will look something like this. If you draw it with negative, still radius is sigma x by 2. Your Mohr circle will look like this. So your options are option B or option C. Is this clear with?
Yes, sir.
Okay, perfect. Thank you. Other people, guys, any other question? Sir, what will be the solution if cross section was from neutral line? They will not do that because at neutral line, your stresses are zero. If your stresses are zero, there is no Mohr circle there. So this is the point, or this is the neutral axis where your stresses are actually zero. There is no compression, no elongation. So stresses are zero means there is no stresses, no Mohr circle. Clear, Dave? Archana, Manish, Divya, guys, is this clear? Divya, you have also done mistake in this. You have given me option B only initially, but you should be very, very much cautious when we are solving multiple select questions. Guys, there is no learning in this. You have to understand the concept so that whatever question comes in your exam, you will be able to solve it. All right, let's go to second numerical. Let's see whether you people can apply this concept or not. So this question is asked in mechanical. I have only pulled it so that you people can solve this now. We will solve the assignments later. I will tell you how the assignment will look like. Let's solve this. The figure shows the state of stress at a certain point in a stress body. You know what is state of stress, right? State of stress means you simply draw a stress system, a block. And if you see, they have given you sigma x. You see, this is tensile, right? Tensile is positive. They have given you sigma y. You know what is sigma y? This is compressive, so it should be negative. The magnitudes of normal stresses in x and y direction are 100 MPa and 20 MPa respectively. So what they have given, guys, let's write in our notation. Sigma x is given as 100 MPa. This is very much clear. But if you see sigma y, its magnitude is 20 MPa, but we know that sigma y here is compressive, correct? So this is minus 20 MPa. And you people see there is no shear stress absolutely. So they have given tau xy to be 0. So they have given me the data and they are asking what is the radius of this Mohr circle representing the state of stress. So everyone knows what is radius of Mohr circle formula. It is sigma x minus sigma y divided by 2 whole square plus tau square xy under root. Sigma x is 100, sigma y is minus 20, so this becomes plus whole square plus 0 square under root. You solve this, you're going to get 60 MPa. I hope I am correct. So option C here is the correct answer. This is very simple, straightforward compared to the question they have asked in aerospace because it is multiple select. So we should not learn anything. If you learn just the formulas, you can solve these kind of questions in your exam. But for this, you need concepts properly, and we will do this step by step. Please tell me, is this question clear for everyone? Any doubt in this? I'm happy to repeat. Come on, guys. Archana, they have not, you see the state of stress in this where tau xy is given. They have not given tau xy is anything, right? They have given you sigma x, sigma y. So tau xy should have been 0, right? Otherwise, they will give you tau xy in the diagram. They will give you like this. If it is present, if it is not present, it is 0. Clear? Good. Let's see another numerical. Very slowly. This is asked in an IES exam. All right. Don't worry from where it is coming. Just understand the concept. Two-dimensional state of stress. Now, when someone says two-dimensional state of stress, directly you should strike that this is the state of stress, or we are just representing this in a block. At a point in a plane, stressed element is represented by a Mohr circle of 0 radius. Then both principal stresses are what? So, guys, I'll repeat the question again. They are saying a two-dimensional state of stress system is represented by a Mohr circle of radius 0. So you have a Mohr circle. Radius 0 means point, right? Radius is 0 means a circle is a point. There is no radius absolutely. Right? Now, radius 0 means, can anyone tell me what is the formula for radius? Sigma 1 minus sigma 2 divided by 2. This is one formula. Or sigma x minus sigma y divided by 2 whole square plus tau square xy under root. Any one of the formula. Can you tell me in which case radius will be 0? Can I say from this formula that radius will be 0 if sigma 1 is exactly equals to sigma 2? Do you people agree or not? Then radius will be 0, right? That means Mohr circle is a point. So when sigma 1 is equals to sigma 2, what they are saying, then principal stresses are, which option? Are equal to 0. No, are equal to 0 and shear stress is also equals to 0. are of equal magnitude but of opposite sign, are of equal magnitude and of same sign. Which option? Option D. They should be of same sign, right? Guys, if they are of opposite sign, then this becomes, let's say sigma 1 is 10. Opposite sign means sigma 2 is minus 10. Then it is not 0, right? Your radius will be coming as 10. Option C is definitely wrong. Divya, again mistake. Rohit, you have done mistake. Dev, perfect. Archana, good. Guys, is this numerical clear? I want you people to tell me so that if it is needed, I'll go in more explanations. If it is clear, I'll move it to next numerical. Is this clear? What do you mean by Mohr circle of radius 0? Your principal stresses should be same and of same sign. If it is not same sign, then definitely this radius will never be 0. Perfect. Good. And my previous lectures, we have already seen this, right? We have seen this case. If you people just quickly recall, we have solved this Mohr circle for hydrostatic case in which sigma x was equals to sigma y. You got a point, right? So we have already seen this case. Now they are not using the word hydrostatic. They are simply saying Mohr circle represents a point. So what you people know about principal stresses? I told you everything can be answered with your formulas. Let's go to next. Again, this is a question asked in IES. Let's see what you people understood with this. The Mohr circle for a plane stress is a circle of radius r with its origin at plus 2r on sigma axis. Let's go slow. You have, don't worry about this plane stress. There is a Mohr circle of radius r and its origin is at plus 2r. So let's draw this Mohr circle first. You know, in Mohr circle, this is sigma axis, this is tau axis, correct? Origin of this Mohr circle is at plus 2r. So let's say this is r, this is 2r. So origin means center of Mohr circle is here. Now your circle is of radius 2r. Now if you people agree, when your center is here and radius is r, now you need to draw a circle. So this is the radius. You people agree this is also radius, right? This is also radius. All these are nothing but radius of Mohr circle. Now the question says, please tell me what is sigma max, maximum value. Now you should tell me what is the maximum value of sigma. If you see, this is the maximum value, right? So if this distance is 2r, if this distance is 2r plus r is your maximum value. Perfect. Good, guys. What is the minimum value? Maximum and minimum, nothing but principal stresses, right? So your minimum value is this. Maximum value is this. Minimum value is this. And if you people agree, this will be 2r minus r, which is r. Then third part they ask is, what is average? This typically they don't ask in GATE exams, but we know it is average is also max plus minimum divided by 2, right? That's it. So it came out to be 2r. And what is tau max? Can anyone tell me what is tau max? Tau max is nothing but radius of Mohr circle, right? Which is, I hope this is very much clear. Are we good in this, guys? Are we clear? Are we understanding this now? Okay, perfect. Let's see one more numerical. I think I have two more. Okay. Let's do this now. This is asked in IAS. Again, I have pulled the questions which makes you conceptually good. So let's draw Mohr circle for all these cases so that it will be crystal clear in your mind. Let's draw it for first, pure shear. We have already done that, but let's revise this again. So what is pure shear, guys? You draw your stress element, and pure shear means you only have shear stresses. That means you don't have any normal stress. Sigma x is 0, sigma y is 0, and you have only shear stress. What is the Mohr circle for this, guys? Can anyone tell me? We have already done this, right? Center of Mohr circle, you know the formula, sigma x plus sigma y divided by 2 comma 0. Sigma x is 0, sigma y is 0. So your center of Mohr circle is 0 comma 0. That means this is where the center of Mohr circle looks like. Next, what is radius of Mohr circle? It is sigma x minus sigma y divided by 2 whole square plus tau square xy under root. Now in this case, sigma x is 0, sigma y is 0. If you solve this, your radius came out to be tau xy. Yeah. So you have a circle with center at origin and radius as tau xy, which is a number. Tau xy will be 20 MPa, 50 MPa, whatever in the numerical. This is my radius. And with this radius, I'll simply draw a circle. So for pure shear, my Mohr circle will be centered at origin. And the radius of Mohr circle will be equals to my shear stress. Shear stress can be anything in the numerical, 10, 20, 50, whatever they give. I think this is easier now because we have already solved this. You people understood this concept easily. Now let's draw it for second case, pure biaxial tension. All right, let me do it on a blank slide. Pure biaxial tension. First of all, slowly draw your stress element. Axial means normal, bi means in both direction, and tension. So in one direction, this is axial and tension. In another direction, it is axial and tension. Tension means both are positive. This is the meaning of biaxial tension. So what is sigma x? It is not 0, but a positive number. Sigma y is not 0 and a positive number. And in this case, tau xy is 0. So if you want to draw Mohr circle for this, it will be a very generalized Mohr circle because your center of Mohr circle will be this, right? Sigma x is positive, sigma y is positive. That means your center is on positive side. Some value, because we don't have number, some value. And you know your radius of Mohr circle formula is this. Tau xy is 0. You will substitute sigma x, sigma y. Some number will come out. So there will be some non-zero value, some value. I'm not interested. 10, 20, 50, 100. That depends upon what is value of sigma x, what is value of sigma y, which one is bigger, which one is smaller. And then you simply, with that radius, whatever value comes, you draw the circle. That's how. The major thing is you need to understand that when it is tension, right? Sigma x is positive, sigma y is positive. So your Mohr circle should be on the positive side. If they both are negative, your Mohr circle will be on the negative side, something like this. But for this case, tension, it is something like this. Is it clear, guys? Everyone, are we okay? And feel free to stop me at any point, guys. We will discuss, we will go in detail, I will try to explain more if it is needed. Is it okay? Clear? All right. Let's see the third case in that numerical, what they have framed. Yeah. Third case is pure uniaxial tension. Now this is very easy, guys. You people know how to draw a stress system, right? Uniaxial means only in one direction. So sigma x is present. Uniaxial tension. So I have marked tension. Yeah, it can be either x or y. Rohit, it can be anything. Yeah, it can be y also. It can be this case also. Yeah, perfect. It can be anything. Both these are uniaxial. Now, if you draw for this case, sigma x is not 0, sigma y is 0, tau xy is 0. And now it's very easy. You people know center of Mohr circle is sigma x plus sigma y divided by 2, comma 0. So if you people agree, the center will be sigma x by 2, comma 0, which is a positive number. Correct? Similarly, radius will be also a positive number. So if you draw Mohr circle for either first case or second case, I hope you people agree that it is on the positive side. And then your radius, let's calculate the radius also. Radius formula is this. Correct? Tau xy is 0, sigma y is 0, so your radius is sigma x by 2. So your center of Mohr circle is sigma x by 2. Radius is also sigma x by 2. So your Mohr circle will look something like this, which touching the y-axis. Is this fine? Okay, good, good. Other people? It's clear for everyone, right? I can give more examples if you want, with numbers also. Perfect. And I hope everyone can draw for uni compression now, uniaxial compression. So I'm just waiting, give you a few seconds. Tell me how the diagram will look like. So uniaxial compression means uni means only in one direction. So your sigma x will be negative, sigma y is 0, tau xy is 0. Yes, Dave. So your radius of Mohr circle will be sigma x by 2. And because sigma x is negative, this number will be negative. I'm not in radius is a distance, right? So don't worry about whether it is positive or negative. But see the center. This is sigma x by 2, comma 0. And sigma x is negative. So you will get a negative value 0. So your Mohr circle will look something like this. Minus sigma x by 2, comma 0. Radius is also sigma x by 2. So your circle will be exactly same, but only in the opposite direction. So please make yourself comfortable between case 3 and case 4. How in terms of tension your circle was this, and how in terms of compression your circle is on this, which is on the right hand side. For tensile, this was sigma x by 2, comma 0. Radius is always sigma x by 2. Here radius is sigma x by 2, but center is on the negative side. Is this clear for everyone? Are we clear in Mohr circle? So this red one is for compression and this yellow one is for tension. Perfect. Very, very, very good, guys. Let's finalize this with the last question. You will get your assignment sheets for Mohr circle only. I will share it with you in group. and we will prepare solution. And if anything, we will discuss this in next lecture again. Let's think about this. This is again asked in IES. So what you need to do is, on left hand side, if you see, there are 4 Mohr circles. All right. So you have Mohr circle A, B, C, D. And on list 2, you have 4 options. You need to do the match. You need to match the following. So can you tell me this Mohr circle here represents which option? Come on, guys. We have solved this. Let's see an option. A shaft compressed all round by a hub. Bending moment applied at the free end of a cantilever. Shaft under torsion. Thin cylinder under pressure. You people don't know this, but it's fine. Let's see the option. You know this, right? Shaft under torsion. Shaft under torsion means pure shear. We have just now solved it. I think I have removed it, but still I can go to my previous slide. We have solved this before. Okay, yeah. Shaft under torsion. We have solved this in our lecture. Shaft under torsion means it's a pure shear system. And for pure shear system, your Mohr circle will look something like this. If you people recall, in pure shear, sigma x is 0, sigma y is 0, tau xy is present, so your center is at origin. And we have just now solved this today itself. Your first case was this only, right? In this case, you also solved this. So for pure shear, your Mohr circle will look something like this. So B represents 3. So option A is definitely wrong. Option B is definitely wrong. Now B represents 3 is correct here. So option C or option D, any one thing. Let's see, what do you mean by bending moment applied at free end of a cantilever? We have also solved this. When you have a bending moment, you only have normal stresses, that is sigma x. Sigma y is 0, tau xy is 0. And in this case, either your Mohr circle will look something like this or something like this. We have solved this numerical today only. First numerical was this. So you have a Mohr circle which will touch the axis. So I hope you can see option A here will look for 2. So here A is 4, which is wrong. That means option. With these 2 things only, you would have marked your option. Now, if you see C is 1, you can check here. This is a point, right? When Mohr circle is a point, this we have also solved. Mohr circle is a point when both your stresses are same. A shaft compressed by all round by a hub, meaning you have a shaft which is compressed all round with the same value. When your stresses are same, then in that case your Mohr circle is a point. So C is also 1. And I'm not explaining this because I have not taken this lecture of thin walled spherical and pressure vessels, but we will do this mostly in 2 lectures. First is Hooke's law, and then we'll go to thin walled pressure vessels, both cylindrical and spherical. But for at least marking this option, you don't need a D option. But I hope you people understood why all these 3 options I have marked. Give me a final nod. Is this clear for everyone? Are we okay with Mohr circle, guys?